Hi, everybody. Welcome to a brand new episode of the Clear to Send podcast. We are excited to have a couple of guests here today to talk about the multifunction radio of an Arista access point. But before we get started, I am here with my co-host, Francois Vergès. How are you, Francois?
I'm very good, Roa. How are you?
I'm doing great. Happy to be recording again. And we do have our two guests here. Our first one is Heather Pane. How are you, Heather?
Yeah, I'm good. Thank you. Nice to be here too.
And we got Robert Ferrolo. Hopefully I said that right.
That's right. Yes. Hello.
Awesome.
Great to be here.
Yeah, awesome. Why don't you guys introduce yourselves to let everyone know who you are, and we'll start with Heather.
Okay, yeah. So I'm a business development director at Arista, and I work on product marketing on our Wi-Fi products with Robert.
Hello. Yes, I'm Robert Fruhl. I'm a GME with Arista Networks, and I'm here to talk about the multifunction radio today.
Awesome. I'm kind of excited to hear about this multifunction radio because the word multifunction, it means we can do multiple things. So why don't we first define what a multifunction radio is?
Yeah, I can do that. So when we refer to multifunction, we're referring to the use of an additional radio in an access point. So a triple band radio that is not being used as an access radio within the access point. So this multifunction radio, it's mostly used in listening mode to continually get and analyze data to ensure that the wireless network stays up and running, and also to ensure that it stays optimized so that it performs in its best possible way and ensures that any threats that may harm the network can be identified.
Awesome. So you have a screen share. So anyone who is listening, you can also watch the YouTube video where we kind of look at what these multifunctions are. So why don't you provide us with what these multiple functions, what can we do with these?
Yeah, so I'll provide a quick overview of the 6 functions of that multifunction radio, and then Robert later will describe them in more detail. But yeah, so together, 6 functions combined together to provide a very well-performing, always-on network. So packet capture, that automatically captures all the connectivity and performance statistics so that it has a good overall picture of what's going on across the network. And then the multifunction radio also acts as a dedicated wireless intrusion prevention sensor to look for unauthorized or rogue access points and automatically take countermeasures to protect the network. So that's doing detection and prevention on the network. RRM is a key feature that scans the network for radio resource usage monitoring for noise, interference, neighboring APs, and also for rogue devices. Spectrum analysis helps network engineers by providing a complete picture of what channels are being used and also what is going on across those channels. It provides representations of raw RF signals, which makes it really easy to be able to identify root cause of any interference problems. And then client locationing is a function that tracks the real-time location of assets and people using the corporate Wi-Fi. And then the 6th one is client simulation for network assurance. So this simulates client connectivity tests. It tests that clients have access to the access points and that clients further have access all the way to the internet. So tests can be done when employees are not actually on site so that any pending issues in the morning when they come into work can be discovered before the employees find them themselves.
It's quite a lot of functions to put into an access point. And I think as a network engineer, usually we have individual tools for all these things, right, Francois? Like I have a tool for packet capture, a tool for spectrum analysis, and even a tool to do these client simulation stuff. I'm curious if this puts a lot of overhead on the access point, or maybe you can kind of go into that detail.
Yeah, sure. And actually, because the radio doing the scanning is mostly in listening mode, it doesn't actually take resources from the access radios. So a multifunction radio is probably the most effective method of doing this, because having a radio dedicated for this means there's no need to wait for access radios to not be busy to scan and find out what's going on across the network. And if we just move on to the next view there, comparing a couple of methods that you can use doing this, you could use a background scanning method. So that uses the access radios when they're not too busy. And that can actually take up to an hour to scan everything. So that includes scanning 2.4 gigahertz, 13 channels, which takes about 1 minute, 100 milliseconds each channel. For 5 gigahertz with 25 channels, the scan time would be 25 minutes, 2.5 seconds. And then with 6 gigahertz with 59 channels, it would take almost an hour to complete the whole scan. Now, with a dedicated multifunctional radio, it's just a fraction of that time. With 120 milliseconds for each channel, let's say there's 25 milliseconds to switch channel. So you end up by scanning all of those 2.4 gigahertz, 5 gigahertz and the 6 gigahertz would be less than 15 seconds, which is a massive advantage. And one other thing just to bring in there is that we also have voice-aware scanning, and that makes sure that using the background method, if a call is in progress, the time spent scanning is much less to ensure the quality of the voice or video call that's going on. So background scanning then would take even longer. It's a huge trade-off between fidelity and understanding and catching what might be going on across the network. So the more time spent scanning, the more secure and safe the network is, but the less time spent scanning, the better quality voice video calls are. And so that's why having a multifunction radio is the most effective, because it's dedicated to doing just that.
I think there's quite a bit to unpack here, because an hour to scan all of those channels means you're probably missing something in between. And so the way I see this is the background scanning means it's the same radio that's servicing clients, right? That's what the background scanning is doing, is it has to take time away from sending and receiving data for users, for devices to do these scans. Is that correct?
That's correct. Yes.
Okay.
And I should add that, we have the feature of background scanning. We do have that feature because not all of our APs have multifunction radios. The vast majority of them do. And with the APs that have multifunction radios, you cannot enable background scanning because it would be unnecessary. And so that feature is not available for APs that have multifunction radios. But for APs that don't have multifunction radios, then you have the option of enabling background scanning, and you have that voice aware option as well. And a lot of our competitors that don't have multifunction radios, they have no choice. They actually, I should say, they have a choice. They can use APs with background scanning, or they can have separate scanners, standalone APs in scanner and sensor mode. And so you have that trade-off. But then you have to have extra cable pulls and extra hardware to be able to do the scanning.
You're basically spending the cost of an AP, but it's not going to be servicing devices. It'll just be doing the scanning function for you. But I do like the idea of this multifunction dedicated radio, because I don't think a lot of us really think about background scanning often and what kind of impact that provides to other features that are presented to you. Because if you're doing something like RRM and it's only doing the background scanning, it's not really going to give you the best results when it takes about an hour. So if it doesn't see that interference within 25 minutes, it's not going to make that corrective change. And going from an hour to scan all these channels, and it's only going to get longer from here, right? Who knows what other spectrum we're going to have down the road, but an hour to scan 2.4, 5, and 6, that takes an hour down to about 14 seconds. I think that's an advantage for network engineers as they try to adjust to the conditions in their environment.
Yeah, I see two big advantage of using an extra radio in the APs. The first one is, like we said, we don't have to deploy an overlay network of sensors to get the data back to the management, console. And I think as we're moving more and more to cloud services and cloud management, I think it's important to get more data in the cloud so we can use that data to do analysis and monitoring and managing, and that gives us the opportunity to do that for every AP all the time, 24/7. So then we can use that data for anything we want to do in the cloud, including the services you guys talked about, location and RRM and all of that.
One other thing I think needs mentioning here, when you mention getting all that data and storing it potentially in the cloud, thinking of AI in general. So artificial intelligence needs good data. So an additional dedicated multifunction radio collecting that data that can be later used for AI-based decision making can further ensure network reliability, just because of the sheer amount of data it can add if it's more efficient, like the multifunction radio.
Let's take a look at an access point in terms of what you can find out about it in terms of RRM, and I'll look at a C360. Here you can see, so this is channel 140, and there's a little bit of information on some other channels, 50.
Yeah, I see. Yeah,
57.
there's a lot more numbers there since we're dealing with 5 gigahertz.
Right.
What's your distinguishing factor there between a weak BSS versus a strong BSS?
Signal strength, but I don't know what the cutoff values are. But it is, it's a signal strength.
Okay, cool.
And so this is, how we build we got, see, we have some numbers here. So this is,
so it's higher
less
number,
inviting
better score
channel. This is the worst score.
Worst score. Okay.
Yeah, you see how there are a number of BSSs, weak and then medium and then strong. Here's one where we do have some Wi-Fi utilization, but you have your weak.
Have a lot. There's more weak BSSs versus medium or strong. So you're trying to also prevent too much co-channel.
Right. Yep. We factor in, so these other BSSs aren't transmitting much right now. Otherwise you would see higher Wi-Fi utilization, but nevertheless the potential is there, right? Because there are quite a few of them. So we factor all that in. And again, you get through these channels so much quicker with the multifunction radio. You could build the table like this with background scanning, but think about how much you trust the data if you're only hitting these channels every several minutes, right? As opposed to hitting them every minute or two, So so it has to do with not just quick speed, but then the fidelity of the data. And that gets to Metka's point too about, for AI, right? Your data, right? Having, the better data, richer data, more accurate, right? Then that you can do more with it, make better decisions.
Yeah, I think it's especially true with Wi-Fi because traffic is not constant in Wi-Fi. It's like sporadic. So you could actually get a high channel utilization because you're scanning at the wrong time. You're scanning when a client is active, but then the channel might be quiet when you're not scanning because that client is done transmitting. So having data more often, I think it's important in this case to, like you said, to have a better fidelity on the data we're gathering.
Right. Yeah. And by the way, here's where you would turn that DCS on. See, this is the automatic ACS, right? Periodic. And again, you can schedule it if you want, say 4 in the morning or something. And then this is the dynamic channel selection. This is saying, hey, if you have some interference, like above a certain threshold, I think it's 70 and for so many seconds. And then so you can, change channels right away. So I keep it enabled.
If you do the scheduled one, will it take the last score or will it look at the average of the last day?
The most recent. It uses the most recent. Yep.
Okay.
Yep. But I'd like to move on now to packet capture. So let me see.
Yeah, packet capture is a good one. Recently, I used packet capture to try to troubleshoot some devices, and I know Metka talked about devices early on, and even before we were recording, we talked about how much trouble we have with devices, and usually the PCAPs, when it gets to that kind of complex issue, the PCAPs help determine what's going on and where the root cause lies, right?
Right. Absolutely. Yeah. And we do automatic packet captures, right? So if a client has trouble connecting, we have this feature where we can enable automatic packet capture. It's per SSID. Off by default, some people have concerns about, person identification and data and so on. But the automatic packet capture happens on the access radios. And that happens if you enable the feature. It strips the payload and it encrypts the packet capture and so on. And let me see if I can find one here. Go to Wi-Fi. Go to my Slack client. Take a look at this one. And let's see here. Here's one earlier today. And if I scroll over here, I can see a packet trace. So that packet trace, that happens automatically. That's using the access radio. Yeah. And so just so that you know that that's a capability, but that's not using the multifunction radio. So when would you want to use the multifunction radio? I like to use the multifunction radio just like I would use my MacBook with AirTool. And so it's like having a discrete sniffer. And when I want to capture 802.11, the packet captures that happen on the access radios are inline. And so you don't see everything over the air. They're unencrypted, they're inline. But if I want to capture over the air, let's say, for instance, I like to, I want to see what the access category, what QoS is being used at the MAC layer, at the 802.11 layer, then I would use my multifunction radio. So I would do that by going to the access point.
So just to clarify, you said the packet capture done at the access radio, the one serving clients, is inline. You're not getting over the air
right
that capture, but your multifunction radio can do the over the air capture.
Right, exactly. And so here are the choices. So when you go, I selected the C360, that's that Wi-Fi 6E, and you can do wireless plus wired at the same time. I'm going to uncheck wired and just look at the wireless options. So the three options here from traffic selection is you can do all the packets on all the BSS IDs. That's inline. That's going to use the access radio, right? So that's that unencrypted traffic. Or you could do a single BSS ID. And again, that's inline using the access radios. But if I want to have that kind of discrete sniffer type look, the way you would, what you would see if you were to use AirTool with your MacBook Pro, for instance, and then I would use this option. Now with this option, I select the frequencies. I can do all three, and I can rotate the channels, or I can do a particular channel. And I know I'm using channel 5 now for a Slack call that I have set up here. And so I can say channel 5, and it's 80 megahertz. I can select the packet types. By default, we're stripping the payload here as well, not just with the automatic packet capture, but on demand as well. And you can see, you can then, filter on the different types of packets. We'll just leave them as is.
Stripping the payload's a good idea for just so people know. For one, it keeps that PCAP size much smaller, and a lot of times the payload is encrypted anyway, so there's not much to do with it.
And it would be here, and you could unencrypt it later on, and with the Wireshark or whatever. But it is, it's encrypted here. So what I'm going to do then is I'll start this packet capture channel 5. I do have a client on the 6 gig radio. It's my Samsung S21, and it is doing a Slack call. It's in a conference call right now. So let's say, I'm trying to troubleshoot a performance issue. Then I might say, well, geez, are we, tagging this track properly? And I mean tagging it over the air at the 802.11. And if I wanted to, by the way, if I wanted to see, well, what about the wire? Do I have the right diff cert code point configured? I would also do the wired capture, so I could see at the IP layer if I'm tagging the traffic properly as well.
Could you do this across multiple APs at the same time if you're not sure where the client is connected to?
No, this is just from this AP, but we do have a feature that will follow a client, and it will give you the conversation that the client's having with the APs and the backend services as the client roams throughout the network, so that it can, for troubleshooting roaming issues, for instance, and other types of connectivity issues. But this one is just from the multifunction radio on channel, on this AP on channel 5. And so I can download the packet capture here. You'll see it pop up here. Now I can open it up in Wireshark.
Yeah, and that multifunction radio, it's great for the capture because your client stayed connected. It didn't drop the connection because
Right.
you
Yeah.
access radio.
Yeah, because you're right. It's non-service disrupting. That's the cool thing about the multifunction radio, that you get all the functions without being, it's not service. You don't have to take a access radio out of service to do this. And so you can see that is channel 5. And let me see if I have any, I don't know if I have filter. Let's see.
Is it, do you guys have 2 antennas for this radio? Is it like a 2x2x2?
It is. It's 2x2.
Okay.
It's 2x2. Yep, tri-band 2x2. And let's see here.
Pretty standards, right now, 2x2.
Yeah, 2x2 QoS. And here you can see, we could see that it's I tagged it as voice, by the way. I have a firewall rule on my access point, an application firewall rule that says if you see Slack, tag it as voice. So tag it as 111 over the radio downstream to the client. And then if you're going upstream at the IP layer, use diffcert code point, CS7. And so here's where, again, I would like, okay, let me verify first if I'm tagging this traffic properly. Even if I have a rule, maybe the AP's, the firewall is not recognizing the traffic. And so I want to make sure that it's recognizing the traffic. So that's an example of why I would use the multifunction radio.
That's really nice. And you can do 6 gigahertz packet capture pretty easily.
Yeah, exactly. I can't do that with my MacBook, obviously, because Mac doesn't have a 6 gig radio. So yeah.
Not yet.
Not yet. I'm looking forward to that. You can also open it up to packet capture in packets. So if you don't have Wireshark, or you're not, you can just do this from your phone. You could,
I think that part is very useful, being able to do the capture through the dashboard, and then even open up an analysis of that capture in
the cloud
web browser without having to download it. Because there's times where either I don't have a good signal and it's going to take a while to download, or it's just, I think it's much faster this way.
Yeah. So that's the multifunction radio for packet capture.
So let's say you're doing a packet capture, is the multifunction radio doing the scan for the RRM, or is one at a time?
Yeah, it's one at a time.
Okay.
But you're still protected because, like right now I have 4 access points here at home, in my home lab. So while this guy is doing the packet capture, these guys are still doing RRM scanning and whip scanning. And they're sharing that information amongst themselves.
And it's automatic, like the RRM scan will stop when you start the packet capture, and then it will restart whenever you're done. Okay.
That's right. Yeah. And so there are some things you can't do at the same time. So if I'm doing spectrum analysis, then I can't do a packet capture. If I'm doing packet capture, I can't do a client connectivity test or network assurance where instantiate a virtual client. So yeah, they're mutually exclusive. But if it's a single AP in an environment, then yeah, you wouldn't have WIPs scanning or over-the-air prevention, or you wouldn't have RRM scanning while you're doing a packet capture or spectrum analysis. So
packet capture sounds like it's just like an ad hoc function, right? You're not going to do it all the time. You're just going to do it whenever you need that extra analysis.
That, yes, for the multifunction radio, true. For the but the APs do actually the APs do automatic packet captures on every connection attempt. We just throw away the captures where we have a successful attempt. But we're always doing those packet captures on the access radios. But for the multifunction radio, it's on demand. Yep.
And so for the spectrum analysis, I'm guessing it would be the same, because you're using the same Wi-Fi NIC to do the spectrum analysis.
Yes.
You're just opening the modulation gate. Okay.
And also for network assurance, which is the next topic I wanted to look at, share with you. So we have a client connectivity test, which is really not a great name. It's unfortunate, right? I'm hoping we change that name, because when we first started, it always did more than just basic client connectivity. But now, I mean, we've added so many tests over the years. It's just not very.
It's a network engineer in the box. So how did you guys call it at one point?
Yeah, I think so. I think the original, right? We had 3 people in the box. We had 3 people. We had a security expert, and we had a network optimization performance guru, and we also then had a troubleshooting, and I can't remember, but yeah, that was the idea with the multifunction radio. So the client connectivity test, let's see. So what we're doing here is, again, we're instantiating a virtual client on the multifunction radio, and then we're going to connect to an adjacent AP and run a series of tests, not just between those 2 APs, but then all the way out to the cloud. And so if we take a look here, we can add a test profile and see the things that we can test. So first thing we do is give it a name and then choose the band, so 6 gig, right? And then we can look at the SSIDs that we want to test here. And this is the only one we have instantiated on the 6 gig radio, because WPA3 is required. And so here it would also could do WPA3 Enterprise if you had it radius set up, or NAC. You can then test that as well. You could also test portals, and then your applications that you care about here. You can add custom apps. So if you don't see the apps that you use in your environment, you can add them here just by adding the IP address or the host name. Simulated VoIP, that's AP to AP. It's not the same as a voice call, Vocera, or what ASCOM. So it's not, just because you can get this VoIP from AP to AP to work doesn't mean that your handsets are going to work flawlessly, or even Wi-Fi calling is going to work flawlessly. But it's another perspective and gives you an idea of the environment and so on. Then you have throughput too, so you can do throughput testing. And none of these tests are service interrupting. They're all just doing what clients do, right? Going out, pulling pages to services on the web, doing voice calls, doing uploads.
Yeah, it's just your multifunction radio acting as a client.
Exactly.
So being able to test things even before, for example, an event is happening.
Yes.
You want to be sure your splash page works. If you've got a splash page up, I know a lot of event spaces have some sort of splash page where people need to put in their name and email address. So your test there, as long as you know the page, you can simulate that and be able to show that it succeeds, right?
Right. Yeah. So you can run these tests before the event or before the bulk of the workforce comes in. That's certainly one use case. And then you could also run the tests during the day. Like I have a daily VoIP. And this is an example where, let's say in a certain part of the building at a certain time of the day, you've been getting complaints about voice quality. So you could run VoIP, that time of the day in that part of the building to see, well, is it an airtime problem, congestion, SNR problem, etc. Now, again, just because you can get, like, say you were successful with getting VoIP to work there from Wi-Fi, from AP to AP, again, that doesn't guarantee that your Vocera badges are going to work, because they're obviously different radio characteristics, etc. But just another perspective.
In that perspective of the multifunction radio, is it just deciding which is the strongest signal it's receiving from a neighboring access point, or are you directing it to a specific AP?
You choose. I'll show you when I'll start a test, and you'll see you'll have the option as far as like which APs, but the APs become an option because of a signal strength with respect to each other. So I would only be able to run tests, I think it's neg 75. I could be wrong there, but or better before that. Otherwise, that AP won't be an option.
Yeah, I would see that as an advantage for people trying to schedule tests on different APs,
Mm-hmm.
where you could determine if there is maybe an isolated incident to a specific AP that might be affected on a specific port, like on a switch, like that kind of thing, right? To further help someone get closer to a root cause.
Yep, for sure. Yeah. It's like, and yeah, it's really helpful because, especially again, you could do this testing, from your mobile, or your tablet, whatever, or your laptop from anywhere. And so you don't have, it's prevent, truck rolls, unnecessary truck rolls. Here we can see the results, and we can see the results over time. And we can see the results for all test profiles, all target APs or limited, all client APs, all SSIDs or limited to particular SSID, all bands, and so on. So you get to choose what you're looking at here. And we can look at the results. Orange means that partial failure. Red is total failure. Green is total success. So let's take a look at one that I ran not too long ago, a few days ago. We can see that we have the AP under the test. So the C360 was being tested, and we can see the signal strength, and then channel that was tested, channel utilization. And then we have the AP where they were using the multifunction radio as the virtual client. That was a 260. The SSID that we tested, the band, and the profile, test profile, all tests. And then we get the dissociation, the type of authentication, PSK in this case, DHCP addresses and latency, gateway latency, DNS addresses and latency.
Yeah, you're testing pretty much the whole process that a actual device would go through.
Right.
So you can see where and in what step does the failure occur. Pretty quickly.
Yeah, that's why client connectivity, it's not very descriptive there, because it's we say it's from virtual client to cloud, because here we're going out to the cloud now, and we're doing page pulls on Office 365, and we're reporting the page load time and breaking down the DNS lookup time, the the connection time, etc. And here we have an example of where one failed. It was Zendesk that failed. Now we can set up alerts too. So when these type of tests fail, or any part of the test fails, we can have an alert sent to the administrator for this part of the network, and so they can get on top of it. So they would say, oh, okay, we had a problem with Zendesk. They can reach out to Zendesk at the same time. They can email the user community saying, hey, we know about the problem with Zendesk and we're working on it. So that proactive way. And here where I added my custom apps. So we use Concur ADP, right, or Workday. So you could add those as well, right? Whatever production apps you want to add here. And we can see the VoIP test, and this is where we show the mean opinion score. We can hover over that rating, that 4.4 rating, and find out in terms, break it down in terms of jitter, packet loss, latency, and so on. And then you have your throughput test too. So UDP, TCP, both up and down over the air. So this is a pretty comprehensive, and you can get a good head start on any kind of issues. And again, non-service disrupting, and all these things that I'm talking about today, right? They're all part of the standard license. We only have one license, I should mention that, and so they're all part of that single license. There's no other license for any of this functionality, or for any functionality, period. Single
license sounds good.
Yeah, it makes it simple. yeah, I know. Yeah. So that's network assurance. And let me show you. Let me try to start a test, and if that way I can.
Yeah, I really like network assurance, just because when you have someone kicking up a ticket saying, "Hey, we can't reach Google Sheets," for example, like you could replicate that test on the same SSID and on the same access point that the device is connecting to, be able to confirm if it is a Wi-Fi issue or even a network issue at that point. Or maybe it's just the individual client, right? You can really tell if it's a widespread problem.
Right. Yeah, that's the idea. And to run a test, I just go here, run a test now, so on demand as opposed to scheduled. I just type in whatever I need to identify the AP that I want to test, and I say continue. Now it's going to give me the options of other APs in the area that are close enough. And we have some that are very close, and we have one that's a little farther away. So now I can select any of these access points to run the test. I won't start it because it will take about 12 minutes to go through all the various tests, and, with all the voice and doing all the page pulls and the throughput tests. So I won't start that now, because then we won't be able to do some of the other things we want to do. But this is where you would choose. So this is like, if I were to choose the 260, then it would be the 260's multifunction radio that where the virtual client is instantiated, connecting back to the 360. So
I guess considering having supporting like a Docker containers, so you could have third party running their app directly from your AP.
We don't support that currently, but potentially we talked about it, but today we don't do that.
Okay, I was thinking about I was testing a service that can analyze your network traffic based on, they do it based on HTML request. And it's pretty extensive what they have, but the way it works is you install it as an extension to your browser, but each client has to install it. So I'm thinking if it's installed at the AP level, then that could make it way easier for them to deploy the service. You wouldn't have to, install it on each client. You can just install it at the infrastructure level, at the access level, and I don't know if it's doable because they gather a lot of information from the browser itself. But I mean, maybe some other applications will be nice to have, like running as a Docker container, so you could support other applications directly from the access point.
Yeah. I'm thinking about NDR, like NDR may be one of them, because we do have an NDR agents now that we can run on our switches. So we haven't moved it out to the AP yet, but that would be one that may be something that would be
yeah, I know some people do it for IoT purposes as well. Or I mean, in your case, the network assurance is already pretty extensive. You can do speed tests and stuff like this. But you could also have like an iPerf server or something very basic.
We do.
I'm guessing that's already part of it, right?
Where we actually do have iPerf servers. So we do have the ability via the AP CLI to connect to a client and run iPerf tests to the client, to clients, but it's not here in the GUI, but that capability there. So that was network assurance. Now we can move on to WIPs, if I may. And with WIPs, right, there's a lot you can do with access radios and background scanning. But one of the biggest things you cannot do, one of the biggest challenges if you try to do WIPs and background scanning, is over-the-air prevention. And so that's what really makes a difference in terms of the ability to prevent different types of threats. So let's take a look at the screen where we configure both monitoring and then also prevention. So if we take a look at our WIPs configuration, security, if I go to devices here and look at security, and I look at the channel selection, so these are the channels to monitor. And you'll notice here that you'll have channel 12, 13, and 14 selected here in the US. Interesting, right? I can't broadcast on those channels, but I want to know what's out there, because sometimes hackers aren't going to play by the rules and they may try to hack on channels that are not allowed here under this, the FCC. And so you can see how the different channels that we have selected. You'll see more channels than we can actually broadcast on. And then 6 gig. Well, look at all the channels that we have to defend basically there, or monitor. And then you have your channels to defend. Now what this means is channels to defend, this implying over the air prevention. So how are you going to defend all these channels over the air if you're doing background scanning and you're servicing clients, right? It's really not feasible, because you would have to.
What does defend mean too?
Sorry?
And also, what does defend mean?
Yeah, defend means transmitting traffic, some different techniques. So the classic example is DDoS. So if you're being attacked by a man-in-the-middle attack, right? Then the multifunction radio can send DDoS both from the client to the AP that's attacking you, and then from the spoofing the AP and send DDoS back to the client, so that preventing that connection that way. And that works great, right? If we don't have 11.w, right? And most networks aren't using 11.w today. So that's a classic example. There are other examples too. like when you have ad hoc networks, we have a technique called cell splitting, where we'll put up another cell and try to confuse the connection. And so that's another technique of over the air. Or we can put ARPs in the air that are bogus ARPs, right, for like ARP poisoning. And so, but you're transmitting, right? You're not just listening, and you can't. Let's say you have an attack coming in on, say, channel 36, right? There's an attack on channel 36, but none of the APs in your area are on channel 36. Now you could change channels on a van access radio and try to go between servicing clients on that radio and then going off channel. I mean, not going off channel, but then sending DOTs. It's not very effective though, because they're pretty clients are pretty aggressive and they're going to try to keep connecting. So you'd have to keep transmitting and to the point where it would interfere with your background. I mean, your voice traffic and so on, your real-time traffic. That's if it's on the same channel. But if it has to go off channel, you're not going to be able to go off channel effectively. Let's say your AP's on channel 36 in the area, but the attacks come in on channel 52. So you'd have to take the access radio off channel 36 to put it on channel 52 and do the DOTs or whatever, the ARP poisoning or cell splitting, whatever, and then go back and service. It's not feasible. It doesn't work. So you really need a multifunction radio where you have the flexibility to be on any channel wherever the attack's coming in. In fact, the ability to go from channel to channel. So when we do our demos, our WIPS demos or WIPS POCs, we'll have like 6 different attacks and use maybe 4 or 5 channels, and we'll have the one access point being able to prevent all those attacks simultaneously, because it's going from like channel 36 and we'll do some de-authentications or whatever, our poisoning over the air, then it will go to another channel and it just rotates through. And so again, it's not servicing any clients, so it can do that full time. And so that's why it's really important to do the to have the multifunction radio. And you might say, well, does 11W break WIPS? Well, that's interesting, because that's a topic that's pretty right now. It's a very hot topic, and I can't talk about it much because we haven't really talked about it much externally. But rest assured that we've been working on it and doing some R&D around it, and so we'll have more to talk about in the near future as far as how do you prevent attacks over the air when you're using which is mandated with OWE and basically with WPA3, management frame protection or protected management frame is mandatory, right? So how do you do that? How do you prevent those kind of attacks? But we'll have to stay tuned for that. A little teaser. So any questions about the multifunction radio and why it's so important to WIPS?
Yeah, I was wondering on 6 gigahertz, because it's still early on. Matt kind of mentioned that at the beginning. Did you guys see any new attacks that are being targeted, or is it just the same man in the middle and the other attacks that we've seen on the other frequency band?
Yeah, I've been waiting for the Wi-Fi Pineapple to come out with OWE, supporting OWE, because that would be brutal, right? And whether or not that's on channels, 6 gig or 5 gig, it doesn't really matter. But it's really the thing that I've been concerned about really is mandatory protection management frame. Because if you think about it, they fix one thing, right? By okay, we're going to do now, you're going to have to do protected management frame. That's good because it solves some problems. But if you have, say, for instance, a Wi-Fi Pineapple doing OWE, people are connecting to those APs and like a honeypot or something like that. And now you can't do over the air, well, with the current methods that are out there, de-authentication, it's not going to work, right? Because you're not going to be able to get into that conversation. You can't spoof the attacker now because you don't have the key. So you're not going to be able to. You
can see the clients connecting, but you cannot do anything about it.
Exactly. And with the current code that we have, we would show you on the map, okay, here's where the attack's coming from. This is where, you need to go investigate. We could show you on a map by doing trilateration where the attacker is. but we can't do automatic prevention right now. Like I mentioned, we've been doing some R&D, and we'll have more to talk about with new techniques. But yeah, so we fixed one thing as an industry and we broke another. I don't know if they thought about that when we came up with the management, mandatory management protection frame. And so the last thing I want to talk about is spectrum analysis, which is having a spec and for 6 gigs. So again, we'll go back to the C360. We'll take a look at.
Yeah, interested in that. There's not too many 6 gigahertz spectrum analyzers.
Right. Yeah, so we can do 2.4, 5 gig, 6 gig simultaneously, or we can just do 6 gig. We'll take a look at that. And let this pop open here. So we have different views. We can look at the signal strength,
and I'm curious too, with the resolution as a spectrum analyzer, like to what depth can you get with it from the AP's perspective?
Yeah, it's not a. This radio that we're using is the multifunction radio, so it's not a purpose-built spectrum analysis radio. So right, the resolution is not what it would be if you have a radio that's all it does. It's designed to do spectrum analysis, but it's helpful. And so you can see here we have the signal strength view, and we have the duty cycle view, and then down here we have the spectrogram and spectrum density. And right now we're looking at the lower 6. We can take a look at the upper 6.
Yeah, it's not too bad. We get something. And
yeah.
You start to understand what's happening.
Yeah, exactly. Yeah, it's not as good again as the standalone, special purpose-built spectrum analysis, but it's a view. It's something to get an idea of what's going on out there. So
this is detecting any signal in the 6 gigahertz bands. So this could also be any incumbents on these channels.
Right. Yep. It could be Wi-Fi or non-Wi-Fi interference. Yeah. And right now, we don't have the ability, when it's non-Wi-Fi, we don't show you or try to classify what it is, but that's in the next release. We almost made it to this current release that we're looking at right here, but it didn't quite make it. So it's been rolled, but the feature's built, but it will show up in the next release. This is 13.0. It'll show up in 14.0, which is in the Q1 of next year.
Okay, not bad.
So yeah, so those are the 5 functions: RRM, packet capture, network assurance, WIPS, and spectrum analysis. Okay, so now we're gonna talk about the 6th function, and that would be the locationing. And I'm gonna show just a few screenshots here, just to talk about the different types of locationing that we do. Wi-Fi based, Wi-Fi based locationing, and that's what we're talking about today, not Bluetooth based locationing, because we're talking about the multifunction radio. But you guys know we support, just so and if you guys want to know, that we support Bluetooth locationing as well. We stream both Bluetooth and Wi-Fi, telemetry. And we don't do Bluetooth internally. We don't have a Bluetooth locationing engine internal, but we can work with third party. But for Wi-Fi, we have our own locationing capabilities built into the system.
So that's what you're showing right now.
Sorry?
That's what you're showing right now on
that's what I'm showing right now. Okay. And we'll start with, I guess, we can start here. We'll talk about how we do trilateration using the multifunction radio to see what's out there in terms of the clients and the RSSI. And then we do trilateration internally. And we do that basically for the purpose of identifying clients that are having issues at certain locations. So you can look to say, show me the clients that are having performance issues, or show me the clients that are having connectivity issues, and so on. And that's done real time using the multifunction radio as the receiver sensor.
So do you need to see the clients from at least 3 radios to be able to locate it? Okay.
That's correct. Yep. That's right.
So,
And,
so 3 is the minimum for accuracy, right?
Yep,
To
3.
get really accurate data, you need three surrounding APs.
Yep, that's a minimum, right? Exactly. Let's see. And the other one I want to talk about is the ability to locate threats, right? And I'll do that. This is a dry run, right? This is a rehearsal. So if we go into WIP's monitoring here, we can see we have the categories of access points and also clients. And so we have, let's see, and we can look at, like, say we have a rogue here. We can say, locate this rogue. I haven't tried this yet, so it's good that I'm trying it. I'm not sure, because if we don't have a map for this location, we do have a map. Good. So I'll do that one. So it shows you on the map where the rogue is.
Mm-hmm.
And
really
that works
cool,
for
actually.
clients too. If you have a client, either a lost client or a client that is a rogue client or misbehaving client, and you want to locate it, you can do the same thing. Let's see here.
Your coffee machine. Was your coffee machine a rogue client?
No, it may be. Let's see. I can filter on. Let's see, filter coffee. I don't know where that is.
You just had it disconnected. Yeah, you had it. No,
there it is,
good.
right there. No, but if you say, hey, that's a good one. That's a funny one. If you want to say, hey, help me find this coffee machine because I need a coffee. It shows you where the
That's a good use case.
is.
That's a good use case.
Should we do that one?
That's where you go for coffee.
Yeah.
That's actually really cool to locate clients using the radio.
Yeah. So yeah. APs or clients, we can locate them in real time doing this stochastic trilateration.
And do you only use the scanning radio or the multifunction radio to do this, or do you also use the radio the client is currently associated to get like an extra reading from that client? You see what I mean?
No, I do believe it's the multifunction radio. Yeah, that's what I've been told. Yep. But I have, I've heard that stated that way multiple times from multiple sources. So yeah, I think it's multifunction radio.
Makes sense.
Yep. I'm not sure when we made that transition, because before we had this feature that I'm showing here with the locating of rogue APs or lost clients or rogue clients, whatever, misbehaving clients. We had that feature before we introduced the multifunction radio. So way back when, it was on the access radios that we did that.
So do you use the location today mostly for, like troubleshooting purposes, or do you use it for like business applications where you would use that location to do something else?
It's for two reasons, really. For threats, and for rogue APs, rogue clients, misbehaving clients, etc., honeypots or whatever, and then also for doing what we call cognitive mapping, which is where you go to the floor plan. Let's say floor plan here, and you're trying to locate clients that have specific types of issues and find out where those issues are happening for those clients. So we could say like low data rate. Show me a client that has a low data rate. And you can see this client is connected, it's over here and it's connected to an AP here. And
it's moving. This client is moving, right?
Yeah.
Earlier it was, yeah.
And this client, oh, by the way, this was just so you know, we purposely designed this network, this particular location here, poorly, so we would have issues.
Okay.
The last function I want to talk about today is the locationing capabilities of the multifunction radio. And that's where we're using the multifunction radio as a sensor, looking at client and AP telemetry, right? Looking for signal strength. And we're doing trilateration from 3 or more access points in the area to determine where an access point or a client is. Now, we're doing this for 2 main reasons. One is a feature we call cognitive mapping. And cognitive mapping is where we're looking at clients that are having specific issues, whether they're performance issues, like low RSSI, trying to see if we have any coverage holes, for instance, or high retry rate, see if we have high congestion, perhaps, or high interference, sticky clients, poor app experience, and then also connectivity issues, authentication failures, and so on. The idea is that can I show you on the map where clients are having different types of issues, then maybe that will help us get to a root cause quicker, or at least get to a remedies quicker. And so that's one of the main functions of the locationing capability. Another one is for any types of threats, like locating any rogue APs, rogue clients, misbehaving clients, man-in-the-middle attacks, honeypots, et cetera, But let's just click on one of the clients here just to show you how it might work in terms of locating a client that's having an issue. We have a couple of types of clients having issues, or two types of issues, network failures and low data rate. I'll click on low data rate to see where that client may be that's having low data rate. And it shows that the client here, we have a TME Mini 04, and it's showing that the client's having low data rate there. And you might see, okay, well, this client's connected to an AP that's rather far away. There are other APs nearby that the client could connect to, but for some reason it's not. I can tell you the reason why it's not in this particular case is we purposely have this set up right now, so this client would be a low data rate or a low RSSI, and because we want to show this off. And so the SSID that's on that it's using, it's not actually configured on the closer APs. So if it were, by the way, I should mention that it would also trigger a sticky client issue, because that would be where the client is connected to an AP that's far away when there are other APs nearby that could service it. But again, we're using the multifunction radio, so that there's 3 or more of the APs in the area using that multifunction radio to sense to hear the client and see the RSSI, and then report that back to our own internal locationing engine. So this can help you get to quicker resolution in terms of troubleshooting connectivity or performance issues for particular clients. Now, the other feature, let's go over to monitor mode here, and we're going to look at WIPs. And this is a feature that we've had for many years, actually longer than the cognitive mapping feature there. But this is about security. So if we go into the WIPs monitor mode here, we see we're monitoring access points and we're monitoring clients. Now, we're monitoring access points and we're categorizing access points in terms of whether they're authorized, whether they're external, whether they're rogues, or they can be uncategorized as well. And we do the same for clients. And the way we categorize clients is based on behavior, right? So an authorized client is a client that connected successfully to an authorized access point. A rogue client is a client that previously connected to a rogue AP, now could be compromised. External clients, those are clients that are connected to external APs, and we never want to bother them because they are, they're our neighbors, and we want to be a good neighbor. So access point. So with access point, if you get a report where we see, or we get an alert, oh, there's an access point, what we could do is we could go here for that access point, and then we could say locate, and it's down at the bottom. Like I say, locate, click on that, and then it will do that trilateration again, and using the multifunction radio to show me on the map with the approximately where it is within several meters. It's not super accurate. We know the limitations of RSSI, Wi-Fi based RSSI locationing, right? It's never going to be super accurate because you don't know what the attenuators are between, from the different radios, et cetera. So yeah.
But it's a good start with locating it on a map, because I'm used to seeing rogues just on a list. Like, here's your list of rogue APs, and then not really knowing where they are. I mean, I could try to guess based on which access point it might be nearby, but just being able to visually see it here by clicking locate and then going straight to a map, I can send someone over there to that area fairly quickly and say, hey, it's in this general vicinity between these 3 access points. Can you find it? And so you get to it much quicker. Right.
Yep, that's right. And by the way, it's Arista. Yeah, even though an Arista AP can be a rogue, right? Because for us, a rogue is any AP that's connected to the network that's not authorized. So you could have Arista APs or any manufacturer AP be a rogue if it's an AP on the network and it's not authorized, and that authorization happens at the time of deployment. And if it's not authorized, then we'll consider it a rogue and a threat. So that's for locating APs, but you could also do the same for clients. So let's say you have a client that is a rogue client, again, a client that had previously connected to a rogue AP that could be a threat. Or you have a say a MiFi, and you have a policy no MiFi on your network or in your space. Or it could be a man-in-the-middle attack or something like that. You could locate those, or not a man-in-the-middle attack. That would be actually an AP rather than a client. Or it could be a misbehaving client, a client that is supposed to be connected to an authorized AP, but it's connected to a neighbor AP. You could locate that as well, as if it's in your your airspace, so to speak. Or if you really just need a coffee and you want to know where the coffee machine is located. And so this is not a threat, but it could be something that you need to take care of right away, right? And let me get these out of here and say, oops. Let's see. I'm going to hide these. Oh, I'm not able to locate it now, so I'm going to have to go without coffee. Let me use a different example.
Hopefully you know where it is.
Yes. Yeah, let me see if I can find any. We have a rogue client in this location. We do. We have one that's a rogue client here. So we can say locate. And so the rogue client is actually here. Not too far from where the rogue AP was.
He's hiding in the stairwell.
Yeah, but we're there. Yep. And so, yeah, so we can find the client that way. Now, you could also use the locate a client if you're just trying to find a lost client. As long as that client is, on its radios on, you can then locate a lost client as well that way. So
I think that feature is really useful because in higher ed, there are certain cases where people go, hey, we have a laptop that was stolen. We just need to know if it comes back or where is it, or it's missing. Where did this device go? Another use case is they're trying to locate a specific device because it's attached to a person and it's a person of interest. So they need to know where that person could be in this building. So this is one way to do that as well. I've had those specific use cases come up, and for me, without a map, it does take a while to come up with it and say, hey, he's in this general vicinity between these two access points, but then users don't really know which is which access point, right? They just know they go in a building, they see access points, but they don't know which one's which. So being able to show them a map and go, hey, here's the approximate location of this device is going to be useful for them.
Yes, we think so. Yeah, thanks. That's very, yeah, I think it's definitely a helpful feature because people are asking for that very often. Customers ask for that capability.
You can get context as well. Like if you're troubleshooting an issue, everything comes to you and they say, this specific device is having issues. If you locate it, you have a better idea to, you have a better idea where it is, and maybe that can change the way you troubleshoot the problem as well. It gives you a little bit more context, especially if you have like multiple campuses or buildings or a large network, in multiple cities. I think it's helpful.
Right, for sure.
Mm-hmm.
So that would be the last function for the multifunction radio, but now maybe we can talk about some potential future uses. We have some ideas, but we can just start brainstorming.
Go for it.
Yeah, okay. So one of the things would be like a auto mesh for high availability. That would be one capability. Like, so for instance, if you don't have mesh, right, you're wired, all these APs are wired, but then for some reason we lose the port or the switch upstream, or we still have power, but there's some kind of connectivity issue here. You could maybe do an auto mesh to a nearby AP using the multifunction radio.
So then you would change it from a scanning to
back off.
Transmitting. Yeah.
Yep.
Okay.
Yeah. And then there are, let's see, I took some notes about additional access. So turning it into, so instead of a 3-axis radio AP, a 4-axis radio AP, maybe where you're doing dual 6 gig or dual 5 gig, for instance.
Dual 6 gig. Yeah, you're talking about the future here.
Yep, possibly. Yeah.
Yeah, that's I
yeah.
haven't even thought about dual 6 gig yet.
Yeah. Multi-client stress test. We do have that feature we talked about already where we instantiate the virtual client to do that network assurance testing, right? But how about instantiating instead of one virtual client on the multifunction radio to do the, end-to-end testing that we talked about? How about instantiating 100 or 200 virtual clients and have it connect to adjacent APs? And now the idea there is you're stressing out your AAA system, or if you have captive portal, whatever, captive portal, or your DHCP server, et cetera, or DNS. So if you have a number of these APs that do these multi-client stress test capabilities, so you can have 1,000 clients or thousands of clients hitting your AAA at one time or your NAC at one time to stress the network that way.
Yeah, I can see that feature being used, especially when people are deploying additional servers, or maybe they're migrating to a new server and want to be able to test that it could handle that capacity. Maybe there's an event coming and you haven't had 300 people show up to your office, and you want to be able to test kind of like an all hands type of situation and everyone connecting. That would be a good use case.
Yeah. And the other one that I heard mentioned before was a wireless console. Yep. And so
connect wirelessly to the multifunction radio in order to see what's going on the AP.
Yeah. So you don't have to get a cherry picker or
ladder
whatever to get up into the ceiling.
That's pretty useful.
It wouldn't be as exciting then, getting on a ladder, dangling your laptop.
Yeah.
But hey, it'd be safer for us network engineers, and we shouldn't be getting on ladders anyways.
Right.
Yeah, and I've seen some people do that with the Bluetooth radio, but I guess you could do that with the Wi-Fi radio too.
Right. Yeah. It's doable with a Wi-Fi radio.
Definition of a multifunction.
Yeah. It's actually a feature that where I used to work, we had that capability. I demoed it using the Wi-Fi radio as a console, but we never actually released a GA of it. So it's definitely doable.
I would have found that useful. I think last week I had a scenario where a user was on site, AP wasn't operating properly, and I needed something from the AP to say what was going on. And I think that would have helped because the AP was about 15 feet off the ground.
Right. Yeah.
What about using the multifunction radio to do self-location, using like 802.11MC and talking to the other APs to kind of self-locate each other on the map?
We have that capability built in to our APs. Well, the MC portion of it, our APs support that, but we haven't done the locationing part, the whole application. But that would be cool. Yeah, sure. That would be, again, locationing, but using the multifunction radio instead of RSSI based on, do it based on round trip time. And, what's interesting about that is because, there's one of the shortcomings of that is clients have to initiate that, right? That you can't force a client to participate in that type of locationing. Clients have to initiate it, and not all clients support it. But the chip that we're using for the multifunction radio supports it.
Okay.
And so it could initiate that, right? That round trip time locationing.
Yeah, because I was more thinking about like AP to AP communication.
Yep.
So you can kind of maybe use that data to estimate.
That's right. Because since the radio supports it in acting as a client, it initiates it to the nearby APs, and as long as you have one AP where we know where it is, as a reference point.
You need a few references, but
probably more than one.
Could possibly tie into your auto mesh as well. Maybe that part of that algorithm to determine which AP it should connect to.
Which AP is the closest?
Yeah. maybe just as a metric to the whatever the algorithm is as it tries to determine which AP is it going to connect to for the mesh.
Yeah, I like that. I like that. Yeah, because well, we're going to GPS, right? But
well, you could
but
use the
still,
GPS to
yeah.
get the anchors.
Yeah, you get your anchors right, exactly. Yeah, and then
Even
go from
even though
there.
GPS is might not be like accurate enough for indoor, right?
Right. Yeah. So you get your anchors and then you go from there using fine time measurement. Yeah. That's a good idea.
Anyway, that's
Yeah.
it's
And
cool.
that's yes. And so so we just to mention, so we talked about locationing. That's one of the other locationing capabilities that's there right now, and for locating clients, right? But then we also do Bluetooth locationing. We can support Bluetooth locationing, but that's not part of the multifunction radio. Separate radio.
Yeah, that's what I was going to say. It's a Bluetooth radio, separate from the multifunction radio, but really good examples of what the multifunction radio can do, especially talking about future use cases. And I think we were able to provide some use cases, and I saw you were taking some notes.
Yeah, absolutely. I like that. The last one you talked about there, because the challenge, like I said, the challenge was with getting clients to participate in that. But in this case, the multifunction radio acting as a client, we have control over that. So very cool.
Awesome. So is that the end for the multifunction radio part, the features part?
Well, I guess so. Well, we could say mesh, right? We talked about auto mesh for high availability, but even before that, just to do mesh. Right now, we don't support mesh backhaul on the multifunction radio. That would be a new feature. We support mesh backhaul on the 6 or 2 or 2.4 or 5 gig radios, but being able to use the mesh, the multifunction radio for that would be good, because then you'd free up the 3-axis, all 3-axis radios would still be available. We could brainstorm a little bit about some ideas, and I can kick it off.
And could you think about, I know we don't really do that in Wi-Fi really, but some companies have proprietary protocols, and they do have different ways to route the traffic, but maybe you could use that third radio as a way to create like multiple path in the network back to the network, so you have some sort of reliability, instead of having one path to the, you could have multiple path for mesh. For mesh, or just to distribute the traffic throughout. I guess the AP will be connected via Ethernet, but you never know, maybe the Ethernet connection is not as good, or you see what I mean? Maybe it would be more of a backup solution, of a way to get back to the network if something fails on the other way.
Yeah,
so
by doing
PoE, but for some reason can't use the Ethernet as backhaul, so using the multifunction radio to get out to another AP that does have.
By doing probing and basically doing latency measurements for the various ways to get from point A to point B, and then
or you could use it as a redundant way to get access, get back to the network. So if you lose your cable for some reason, then it will
auto mesh, like auto mesh,
yeah,
something like that. That would be cool. Auto mesh. Yeah, that would be really cool. Like, okay, cable goes down. Okay, turn my multifunction radio into a mesh link into the nearest
uplink. Yeah,
auto mesh. I like that.
And then it becomes the uplink, and
for for HA. Yeah, I like this.
Just make sure you don't enable that by default, because other vendors do, and then it's a pain because you don't know which AP is not connected properly, right? They're all up, but half of them are mesh. It happened to me.
Oh wow!
Yeah, the cable is not good, but the AP is online because it just it meshed to another AP, so everything looks good, but the cable is not. So you don't really know unless you do you take a deeper look at it. If you just do a site survey, you'll just see all of the APs are up.
Right. Yeah.
Yeah.
That's where the UI would, if it can show you what's live and what's down,
Yeah.
how, showing you green path and red path.
Yeah.
That would be
Or
very
different
helpful.
colors. Yeah.
Yeah,
Cool.
I mean that's a lot of a lot of functions from the multifunction radio, right? So talking about RRM scanning and having better input into what channels an AP should be using, packet captures also with 6 gigahertz Wi-Fi 6E, useful for troubleshooting for us as we try to verify and validate operation. Then you've got the network assurance. I like network assurance feature when just needing to know if the Wi-Fi network is doing its job and where else the other failures could occur, and have users blame Wi-Fi for that. Then WIPs, which not a lot of people talk about, but security for us should be part of that layer that we are keeping our minds on. And then of course spectrum analysis. I think it's probably just beginning for you guys. I don't know anyone else who's doing spectrum analysis on 6 gigahertz, but definitely could see some improvement there. Or maybe some other adapter can be used to provide higher resolution. I understand there could be some limitations to what the actual radio can do. It's not a full spectrum analyzer, but it gives us another data point that we could work with.
Yes. And then the future is a good idea. It's got a wireless console and auto mesh. Those 2 ideas, and those are new. For sure. Yeah.
You'll have to come back to us to test them.
Yeah. Auto mesh too. That one I'd like to see. That'd be totally cool.
Well, thank you, Robert, for going deep into those topics and showing us your screen with a demo. So for anyone who is listening to this and would like to see what it looks like, head over to our YouTube channel. I'll set up a short URL. If you go to cleartosend.net/Arista, you'll be able to see this episode and as well as some other episodes that Arista has done. But I want to thank you a lot for educating us, Robert.
Well, thanks for having us. It's been a pleasure. Thanks for your ideas.
Yeah, thank you.
No worries.
And if anybody has any comments or wants to provide any feedback, you can do so in the comment section of the show notes page or even on the YouTube video page. But we'll see you guys on the next episode. Thanks, guys.
All right. See ya.
Thank you.
Thanks.
Bye-bye.
Bye now.